Let's take a look at another correlated subquery. So in this video, we're going to try to solve this question right here. We're going to try to print the number of orders for each product. So for example, if we consider the first product right here just by itself, the first product has an ID of number 1. So I would want to find the number of orders that are tied to this product. If we look at our orders table, we would take a look at the product ID column, and we would try to find an order with a product ID of 1. In this case, there's one right there. So the first product has one single order tied to it. So I want to print out maybe just the name of that product and then the number of times that it has been ordered. So in this case, it would be just 1. We're then going to repeat that process for every single product. So that's our goal. But there's an additional little requirement on here. I want to try to solve this without using a join or a group by. Now, without a doubt, let me be clear, using a join or a group by or some technique like that is definitely the ideal way to solve this, without a doubt. But we're going to take an alternative approach where we try to only make use of a correlated subquery. And the goal here is to just better understand how correlated subqueries work. All right, so let's walk through a solution to this together. We're going to understand this from a kind of theoretical perspective and then write out the actual query. The first thing I'm going to do is put together the root query on the left-hand side. It's kind of hard to give you a natural lead into this or kind of like show you naturally how to go about this. It is definitely easiest for us to tackle this thing if we just kind of take a look directly at a solution first and understand it. So the outside query that we're going to put together is going to be select name from products as P1. Now you'll notice right away that we've got the alias on here. Remember that when we are making use of a subquery or a correlated subquery, we are almost always going to apply an alias somewhere so that we can cleanly refer to the outside row in the context of the subquery. Now with just what we have right here, we can imagine once again that we're going to take all the different rows out of products. And then each individual row, we can imagine, is going to be fed into that select clause. So we're going to process each row using the select clause. In this case, we have just a select for name. So we can imagine that we're going to take just shirt right there and use it inside the select. So where's the correlated subquery? Well, that's where the magic comes in. Rather than using a correlated subquery, in this case, in a where clause, we're going to instead place a correlated subquery in the select. That's the trick. We can make use of a correlated subquery not only inside of wheres, as we saw in the last video, we can use them just about anywhere. So in this case, we're going to put a correlated subquery right here inside of the select. So I'm going to imagine that our subquery is going to go like right in there. Now I want you to remember what happens when we make use of a correlated subquery. We can imagine that it is like a double-nested for loop. So as the outer query goes through every row of products, so first this row right here, and then row 2, and then row 3, and then row 4, for every one of these rows, we are going to take a look at every single row out of some other source of data. In this case, it's going to be orders. So for example, if we put in select something, we'll figure that out in just a moment, from orders, and I'm going to apply an alias to that right away as O1, that means that for every single product that we look at, we're going to take a look at every single order. So for this first row right here, we're going to look at every single order. For the second row, every single order. For the third row, every single order, and so on. So as we process each of these different orders, we have the ability to do some kind of computation or somehow reference the value on this order and compare it against a value on the product that we're currently iterating over. So all we have to do is figure out exactly what different values we want to compare between this row right here and this row right here. In this case, we kind of want to join together manually, so to speak, the product ID from the order and the ID of the product itself. So to do so, we might write out a where right here of O1, so that is the order row that we're currently taking a look at, dot product ID equal to P1.ID. So the where right here is saying I only want to keep around rows from the orders table where the product ID, that is this column right here, is equal to the ID of the product that we are currently iterating over. So in this case, we would say, all right, are these two things equal? Is 4 and 1 equal? Nope, it's not. Okay, so we don't care about that row from the orders table at all. So we then move on to the next order. We'd say, okay, is 2 equal to 1? Nope. Okay, we would drop that, and eventually we would move on to the very last row right here. So we're going to again say, okay, is the product ID equal to the ID of the product itself? In this case, yes, it is. So we would hold on to this as the result of our subquery. So now after our subquery runs, after we've processed the from and the where, we are left with just this row by itself. Now in our case, we want to print the number of orders for each product. So for the select right here, we could put in a count star, and that's going to count out the number of rows that we got from the from and the where. And the result of that would be just 1. And so the subquery overall would return 1. And if we imagine the result from processing the very first product right here, we would end up with a product name of shirt and a quantity or a count of 1. And that's it. All right, I know that this is kind of a nasty thing as you go through it, but you gotta just approach this from the thinking of this is like a double nested for loop, and we have the ability to refer to values on the column, or excuse me, from the row on the outside query inside of the subquery. So let's now go back over and write out this entire thing and just make sure that we get something that looks like a correct result. Okay, so over here, I'm going to put in first just my select. I'm not going to write anything in just yet. I'll put in my from, and we're going to take a look at all of our different products as P1. So then inside the select, I'll add in name because I want to print out the product's name. If we want to be really specific, we could put in p1.name just to make sure that there's no ambiguity there. After that, I'll then put in my subquery. So inside the subquery, for every single product, I want to take a look at all the different rows from the orders table. And I'm going to apply an alias there as well as O1. Now, when we take a look at all those different orders, we want to apply some filtering criteria. So we will add in a where, and we'll say that we only want to consider orders where the orders product ID is equal to P1, so the outside rows ID. So get that big list of orders, pare down the list of rows to just the rows we care about, and then we'll get a count of the rows that we found. And then finally, I'm going to go ahead and rename this entire column right here to as num orders. Not required right there, just doing it so that it's really clear when we take a look at our result set what the two different columns we're going to end up actually mean. Okay, so let's run this and see how we're doing. So now I can see the name of every product and the number of orders that are tied to it, and we did all this without using a join or a group by or anything like that. All right. So again, I just want to mention that using a join or group by, probably both of them together, would be the ideal way of doing this without a doubt. I'm only showing you this approach with a correlated subquery just so we can get a better idea of what's going on here. And also to just reinforce the fact that whenever we're writing SQL, there is often more than one way to solve a problem. Okay, so that's it. Let's take a pause here and continue on in just a moment.